Okay, for number 4, we're evaluating another integral. In this case, we're doing integral of ln of x squared plus 1. So remember from your sections on integration techniques, whenever you're taking the antiderivative of a natural log function, you're going to want to use integration by parts, because the integral of ln is not one of your common formulas that you know, and that's all you have here. So when we do our integration by parts, we're going to set that ln equal to our u, ln x squared plus 1, and our dv is just going to be dx, or you can think of it as 1 dx. So therefore, our du, the derivative of this, remember when you take the derivative of an ln term, you're just going to get what you're taking ln of on the bottom, its derivative on the top. And here we're dx, and here we're getting v equals x. So now we're ready to use our integration by parts formula. So we get uv x ln x squared plus 1 minus the integral of v du. So we have x times 2x over x squared plus 1. We can put that 2 in front of the integral, and we get x times that, which is x squared over x squared plus 1 dx. Now this integral is another one that we're going to have to do some work with, but it won't be integration by parts, so this will be the last step. We won't have to do another integral. So in order to make that one a little bit simpler, since our top and bottom are so close, you can add a constant and subtract to make them the same. So if we put a plus 1 minus 1 up there, that's leaving it the same, but that allows us to factor it in an effective way. So if we take x squared plus 1 over x squared plus 1, we get 1 minus 1 over x squared plus 1 dx. So you can see these are the same things. If you got a common denominator here and put these together, you would have gotten just x squared over x squared plus 1. But now those are both integrals that we know how to do. So the antiderivative of 1 is just x, and remember we're distributing a negative 2 to each. So we have minus 2x. 1 over x squared plus 1 is arctangent. It's subtracted here, but we're also multiplying by negative 2, so we get plus 2 arctan of x plus c. And that's each part of the answer. So you can see there that that's answer choice C. All of those answers are really close, so a small mistake would have probably led you to the wrong answer there. But the using that plus and minus strategy when you have fractions is often really helpful to solving these